We'll now begin the study of the behavior of functions given some graph. And to determine this behavior, we're going to be looking for points called min and max. And all the space on your function that's in between a min or max value is going to be either increasing, decreasing, or constant. Let's go ahead and draw a picture, and then we'll define some of these things. Here we're given some graph. On this graph we have two different points where everything around it is either smaller or bigger than it. Here we have a point that we call a local max. And the reason why we call this a local max is because we can take a very small neighborhood around this point, and on the graph every point inside this small neighborhood is going to be smaller than this y value. By a very similar argument, over here we have something called a local min. And the reason why this is called a local min is because, again, we can find a very small neighborhood around this point where all the y values on the graph are larger than the y value of this local min here. As it turns out, the behavior between local maxes and local mins are very well defined. We can see on the left-hand side of our local max, our y values are increasing as we go from left to right. And then, between our local max and our local min, we see that the y values of our function are decreasing. Finally, again, from our local max onward, our function's only increasing again. These points on our graphs, called local max and local min, are the points of change for our graph. If we had a local max that was increasing on both sides, then it wouldn't be a local max. That's not possible. So for local maxes and local mins, these are going to tell you how your functions are behaving from left to right. Let's go ahead and introduce some of these terms as definitions. We say that a function is increasing on an open interval, we'll call it a to b, if f of x is greater than f of y, where x is greater than y, and x and y are in a to b. By symmetry, we can define a decreasing function. A function is decreasing on an interval a to b if f of x is less than f of y, where we have that x is greater than y and x and y are in the interval a to b. Let's go ahead and define our local max and local min. F has a local max at x is equal to b if there exists an open interval a to c where a is less than b is less than c, such that for all x in a to c, we have that f of x is less than or equal to b. Less than or equal to f of b. And we can go ahead and define our local min in a very similar way. F has a local min at x is equal to b if there exists an open interval that contains our b such that for all x in our interval, we have that f of x is always going to be greater than or equal to f of b. let's go ahead and identify where a function is increasing and decreasing. I'll go ahead and draw the graph, and then we'll go ahead and get started. All right, so here's the graph here. And because the graph is a little wonky, I already filled in some of the points. But to identify where a function is increasing and decreasing, we need to go ahead and real fast identify where our local max and local min are. So the points that are local max and local min are given by the points 3, 3, 4, 2, and 1, minus 2. And the reason why we can tell these are local max and local mins is, number one, by the values of the functions there, and number two, these are the points at where the behavior of a function is changing from increasing to decreasing and decreasing to increasing. So from negative infinity all the way up to 1, we know that our function is decreasing. And from 1 to 4, our function is increasing. Then again, from 3 to 4, it decreases. And then from 4 to infinity, it increases. The function then can be summarized as following. The function decreases over the intervals negative infinity to 1, but not including 1, and also 3 to 4. We don't include the local max and local min inside the increasing or decreasing part of our function. Now for the increasing portion, our function is going to be increasing from 1 to 3, the interval 1 to 3, and then it's also going to be increasing from the interval 4 to 2. So again, let me just highlight that everything over here are intervals, and these over here are points on our graph.